Physics, heat transfer and changes in state. So for this we are going to go ahead and do an example of changing water into vapor. So when heating water, a thermometer will basically show you that the temperature will continue to increase as you put more heat into the system. However, once the water reaches the boiling point, the temperature increase will stop. And then the temperature will basically level off and become constant. Even when you continue to put more heat into the water, the temperature stays the same. So what's happening here? Where is this heat going? And why doesn't the temperature continue to increase? So for this, one way that we can look at it is to examine basically a temperature and specific entropy diagram. And on this we have our temperature on the y-axis, and we have the specific entropy on the x-axis. So as we increase our temperature, so as temperature increases, it reaches the boiling point, and then it begins to just level off. So what's happening here is this is actually hitting what is called the vapor dome. And basically what's happening is it is beginning to change state. So it's going from being a full-on liquid to becoming something of a gas liquid mixture. So there's a mixture of vapor and gas inside the fluid. And as you continue to pour energy into it, what's happening is you're actually increasing your entropy. Entropy is given by as joules per kilogram Kelvin. So what happens is when you begin to change state, your temperature will level out and become a constant. And then you will continue to pour energy into the system. And then once you reach a very specific point for your specific entropy, you will change states fully into vapor. So this is actually a little bit easier to see on this chart down below here. So what happens is we have these lines here that are going across, and these lines are basically constant pressure lines. So constant pressure lines. And these lines, they come up as a liquid, and then they reach the boiling point, and they continue along, they continue to build entropy until they hit the saturated vapor point, at which time they vaporize, becoming vapor, and once they go beyond a saturated vapor, they become a superheated vapor, and if it continues to go up there, then some bad things happen, like the gas ionizes, but we don't worry about that. And this is just for constant pressure. As far as water, you're usually talking about 100 kPa or kilopascals, and so you're always going to be hitting this giant bubble that's in the middle of the graph here. If, however, you have a massively compressed water, then technically, yes, you will completely avoid this bubble altogether, and you will go straight from a liquid to a gas. However, this is very, very rare circumstances, particularly on Earth, and that's basically everything that happens above the critical point. And so that's basically what's happening is you just have to, once you reach the boiling point, you have to continue to increase entropy in order to make a change in state.